All right, what up, team? So, today we have more finding the zeros of polynomials. Now, what is a zero again? Let's remind ourselves. The zero of a polynomial is different than the number zero. The zero of a polynomial is an x value, whatever the x value, happens when y is equal, ignore that, y is equal to 0. So when y is equal to 0, when my output variable is 0, what do I need to have for my x to make that true? What input do I need to have in my function to make y equal 0? Whatever it is, that number is a 0 of my polynomial because it makes y equal 0. So in the past, in the previous couple videos, we've talked about finding zeros for linear equations. Today we're talking about quadratic equations. So a little bit of a review. What is a quadratic equation? Well, when we want to name polynomials in terms of their degree. Again, degree has to do with the largest exponent. When we want to name polynomials by degree, we've got a couple options. We've got a couple names. We can call them linear. We can call them quadratic. And we can call them cubic. And if we call them linear, we're calling them linear because we notice that they're first degree polynomials. Linear means first degree. If we call them quadratic, that's because they're second degree polynomials. And if we call them cubic, that means they're third degree polynomials. Okay? So it has nothing to do with how many terms they have. It has everything to do with what degree are they. So this function here has just an x. Now, when you just see a single variable by itself with no exponent, you know it has an invisible 1, so it's first degree. That's why we call this linear. But if you look down here at this example, you look at all three of these terms. Of all the x's in this x has the biggest exponent. It's a 2. That means this is a second degree polynomial, which means that we call it a quadratic. Sure enough, I've labeled this section talking about quadratic equations, because that's a quadratic equation. It's second degree. Okay, so in this video, we'll be talking about finding the zeros of quadratic equations. Let's just review that process for linear equations real fast. So when we want to find a zero for a linear equation, we got to set y equal to 0 and figure out what's our x value. So in this example, we've got y is equal to 3x minus 1, set y equal to 0. Add 1 to both sides, and I've got that 1 is equal to 3x. I can divide both sides by 3, and what you find is that x is going to equal 1/3. Okay, so we found our x value when y equals 0. That means 1/3 is a 0. Okay, simple enough. That was from our first video on this subject. Things get a little more complicated when you have two linear equations multiplied together. A little bit, but not much. Really not much. Again, we're trying to find zeros, so we're figuring out when y is equal to 0. I'm setting my y equal to 0. When y is equal to 0, what values could I put in for x? Well, because this is one big multiplication problem, all I got to do is make one side or the other equal to 0. And if I do that, since anything multiplied by a 0 is 0, those x values will both be zeros for the entire function. So let's see what x I can get when I make the first linear equation in the first parentheses equal to 0. Well, if I set that equal to 0 and subtract 5 on both sides, I'm going to get that x is equal to -5. All right, well, what happens if I try to make the second parentheses equal to 0? That will also give 0 as an answer. But what x value does it lead to? Well, I could add 1 to both sides, divide both sides by 3, and I get x is equal to 1/3. And actually, if you were paying close attention, you'll notice that this equation right here is the exact same as the one that I solved up here. That's why we get the same x value as in this problem. So, in this equation, where you have two linear equations multiplied together, you get two zeros. -5 is a 0, and 1/3. They're both zeros of this equation. Okay. So I just reviewed what we did in the first two videos. Okay. Now for the new stuff. Okay, this is the meat and potatoes of this video. We're finding the zeros of quadratic equations. So, how do we find the zeros of this quadratic equation right here? 3x squared plus 14x minus 5. Well, it's the same concept. We're trying to figure out what does x equal when y is equal to 0. How are we going to do that? Well, I could try to manipulate this expression with algebra to get one x isolated on one side, solve for x just like I did up here. Turns out that's really, really hard. It's really difficult to do. There's a much easier way than that. Okay? And it involves something we've already covered in this class. It involves factoring. We remember how to factor quadratic equations with the AC method. Okay? Now this is review, so I'm going to do it pretty quickly. If you're confused about this part, I'll put up a video about factoring with the AC method. That'll you can watch if you want to review, so you can know how to do this homework. But since we've already covered that, I'm going to do it really quickly. I'm going to multiply A times C, getting -15. I need to find factored pairs of -15, factored pairs like these pairs that I'm writing down right now. These are my factored pairs of A times C. And then I'm going to try to find the factored pair that if I add that factored pair up, it's going to equal B. So 1 plus -15, that's -14. That's pretty close, but it's got the wrong sign as my B. If I add 3 and -5, I got -2. That's not right. 5 and -3, add those together, and I get +2. That's not right either. If I add 15 and -1, I get +14. That's exactly what I want. That's my B right there. Okay, so here is my pair that I want. Okay, so I'm going to use that pair. How am I going to use that pair? I'm going to use that pair to split up the B term. Instead of having 14x, I'm going to have 15x from that 15 right there, and then I'm also going to have a -1x from that -1 right there. I'm still going to have that -5. All right, so I've rewritten my equation, but instead of 1, 2, 3 terms, I have 1, 2, 3, 4 terms. I got an extra term because I split that B term up into 2. Okay. Why did I want 4 terms? I wanted 4 terms so that I can use grouping. So I'm going to use grouping here. Always separate your groups with a plus sign. So find the greatest common factor. That's 3x for the first group. 3x for the first group. And I'm going to take a common factor of -1 out of my second group. That'll change the signs so that I get matching factors on both sides. I can anti-distribute. I can find that x plus 5 is the greatest common factor of both of these terms. So I'll write that to the outside here. Factor that out. And then if I factor out an x plus 5 from this group, I get 3x left. And if I factor out an x plus 5 from this group, I get a -1 left. Okay? So here's my factored quadratic equation. I took the quadratic equation and I factored it, and this is what I got. Okay, so why did I do that? Well, let's just, this is the same, this expression right here, this equation, is the exact same equation as the equation I started with. You can see it's connected by equal signs all the way to the equation I started with, which means it's equal to the equation I started with. So if I'm trying to find the zeros of this quadratic equation, I could just find the zeros of these two, what turns out to be two linear equations multiplied together. And they're going to be the same zeros because it's really the same equation, just written in a different way. So that's nice because I already know how to find zeros of two linear equations multiplied together. And in fact, not only are these two linear equations multiplied together, these are the exact two linear equations that I figured out the zeros of right up here. Right? It's turned into the exact same problem as I did up here. And when I did it up here, I figured out that if I want y to be 0, x can equal -5, or x can equal positive 1/3. So the same zeros that I found for this equation up here, turns out they're also true for this equation down here. -5 and 1/3 are zeros. And there's my answer. So let's review the steps one more time. When we want to when we want to find the zeros of a quadratic equation, first we factor, and then that gives us two linear equations. Then we solve, and we solve. First we factor, and we solve. Just like this. So I'm going to put up another example video if you want more practice at this, but if you feel ready, that means you can go on ahead and start doing the homework.